Yeah, I watch Deontay Wilder because I know he gonna knock him out in a quick second. But anybody else? Oh, I don't know.
All right. So we got pretty much through this, but I want to talk about a few things before we move on. So when we were looking at, we looked at the tables, we looked at the graph, we looked at the equations. How did we connect all of these to say which streaming service we should choose and why?
You looked at which one was going to be cheaper?
Which one's going to be cheaper? Okay, so which one did we say was cheaper?
What's her name? D for 7 months. 6 months.
And B for 6 months?
And A if you
after 6 months.
after 6 months.
Mr. Lipham, can we make a quick note about note taking?
Yeah, so we're doing a wrap-up discussion right now. What do you think will be important to do during a wrap-up discussion?
Right.
Take some notes, right? So then we can reference back to it later so we
What
know.
should we write this on? Under B?
Underneath or on the back, I'm pretty sure the back is empty if you want to write notes back there. Just something so that you can reference back and say, I believe that you understand it, you can tell it to me now, but later if you look back and you get confused, you won't know 100% unless you take the notes, right? So we said B was cheaper for 6 months.
I thought it was 7.
You changed it to what?
That's a good discussion. So let's look at, is it 6 months or 7 months? We can look at, let's look at our tables. What do we think?
A for 7.
It's in month 7, B costs 137. How much does A cost?
A is 7 for
134.
134. So which one's cheaper at month 7?
A.
A. So B was cheaper for those first 6 months, right? And then after that, A is cheaper. So when we were looking at, does the graph also show that? When we were just looking at tables, does the graph also show that?
Yes.
How do you know that? Where do you see that? So how do you know that B is cheaper for the first 6 months based on the graph?
Because you can see like the increase of the line.
So what does our y-axis represent on our graph?
Just starting value.
So our y-intercepts are our starting value, right? So this is our total cost on the y-axis. So based on this graph, how can I see that B is cheaper for the first 6 months?
Because it's below A.
It's below, right? So it's lower cost up until for 6 months, and then at 7 months, what happens?
A becomes cheaper.
A becomes
It's
cheaper,
below
right?
B.
So what was this? What is this point right here?
Point of intersection.
Slope, point of
Point of
Point of intersection, right?
slope intersection.
Now, what does the point of intersection tell us for a system?
Both of the
equations?
that's where the points intercept.
That's when both of the
Inequalities.
services
Cost
cost
the
the
same.
same.
It's when both of the services cost the same.
Oh,
Now, when we're looking at a system, what does the point of intersection tell us? Just like mathematically.
That it makes both of the it makes the system true.
Makes the system true, what do we call that?
The solution.
The solution, right? So the point of intersection is the solution where it makes both of the equations true at the same time, right? Because we said both services cost the same at the same time. So that's important. So what was this point? Can we just look at the graph and see that point right away?
Nope.
What was it? Do we remember what it was? When we looked at it?
6.2.
5 and 125.
2 and negative 2.
So
Oh, I'm talking about number 1.
we're talking about this point of intersection right here. So we couldn't like immediately see that, right? It's hard to see that decimal right away. But what does that, if we said the point of intersection is both services cost the same at the same time, what did they cost at the same time? If we're looking at our actual point of intersection. What is this point? What does the 6.25 and 125 mean? In the context of our problem.
Which month it is and how much it's going to cost.
So how much month it is, and how much is it gonna cost? So at month 6.25, how much does it cost? How much do they both cost?
125.
They both cost 125. Now, is that feasible?
No,
Why not?
can't have 6.75 a month.
So I can't get a subscription for 6.25 a month, right? So now we weren't really able to see that solution on a table, and if we did the graph by hand, would we be able to see that solution? No. So how could we find that solution algebraically? RJ, what do you think? Wait, if I said let's find the solution algebraically, how would we do that?
You got 30 minutes. Yeah, 3 or
Trey.
So what do we think? RJ, how do you think we could find this solution algebraically? We found it on the graph, but if we didn't have Desmos,
Oh.
and sometimes making a graph can take some time, so how can we find the solution algebraically?
Crane the equation.
What do you mean?
But you said to find what?
We want to find that solution, but algebraically, if we haven't made a graph. Sometimes making a graph could take time, can't see it on the table. What do you think, Trey?
You said without making the table or graph, right?
Yeah, 'cause sometimes the table takes time, and even from the table, we couldn't see the solution, and then the graph, we're making the graph by hand, we won't be able to see it exactly, right?
Yeah, so you use zeros for like the y and the x.
So if we use zero.
No. Y equals 6x plus 25, so you can put 6x plus 25 equals 12x plus 50.
So you're saying like this, 16x plus 25 equals 12x plus 50?
Yes, sir.
Why can we do that?
Because y equals 16x plus 25.
So what are we doing here? If you know, so you know that that's equal to y. What is that word? What are we doing?
Substitute.
Substitution. Good. So we're substituting that in for y. So now,
I just need to calculate.
so now if we've substituted that in for y, Amity, what would you say would be our first step to find the solution? Once we've substituted.
Subtract
You
25.
can simplify.
Okay. Subtract 25.
But can you simplify on it?
What would you simplify?
6x and 12x.
Okay, so what would you do with the 16x and 12x?
I was thinking add it.
Add. So if we added, let's just say add 12x to both sides, what would that get us?
Oh, they want to cancel out.
Yeah, because it's not, we want to find an inverse, right?
Oh, you can subtract it.
Yeah, subtract 25. No.
Subtract. Subtract 12x.
Subtract 12x, right? Good. So that will create a 0 on that, for that, right? So that creates a 0, so you get 4x is equal to 25.
Now we
And
divide.
then divide by 4x.
Divide by 4, and we're only dividing by 4, right? We want to isolate that x, so that gives us x equals 6.25.
5.
Now how can we find the y?
Same
Use
thing.
x equals 6.25 and put it here. Plus substitute
There we go. Way to create doing is to substitute it where?
for x.
For x, and we're just going to do the 12x plus 50, so 12 times 6.25 plus 50, which gets you y equals 125. So is that, did we find the same point?
Yes, sir.
Now remember, when we're finding a solution, the solution can't just be an x or it can't just be a y, it has to be a point, right? So when we write a solution, we're going to write it as a point.
Alright, I got a question.
Yeah.
So, you know how we found the x value, right?
Yep.
Then to find the y value, can we use like any one of the equations?
That's a very good question. So you can, wherever you see that, if you know that x equals 6.25, you can either substitute it there for x or there for x.
Okay.
It will work for either equation because remember the solution, it satisfies both, right?
Yes,
At the
sir.
same time. So you can substitute it into either equation. Any more questions? So I'll give you all a second to write this down so we make sure that we understand how to do this moving forward.
Hey, Duan, have you written all of this down?
Oh,
You know, Mr. Lipham literally talked about this at the beginning of this whole class discussion. If this is a wrap-up, and I need y'all to understand this, you're not just supposed to write down just what's on the board. Just what's on the board is just the work. And a little bit of explanation. But if you just write down the word solution with that arrow drawn to it, are you going to know exactly what that means? You need to be actively writing as you're discussing. This is the final wrap-up of everything to be like, this is why it matters. Write as you discuss. Think. And yes, Dewan, you're going to use Symbolab, but you better not be doing it when it's distracting you from doing what we're doing in class. Is that clear?
you can plug in 125 for the Y.
Yeah, so if we had, so here we substituted one of the expressions in for y, and we solved for x first, and then substituted x to find the y. But if we did it the other way and found the y first, we could have substituted in to then find the x. Okay, are we good to move on? Do we understand how we did this? Yes, Trey? RJ? Juan? Amity? Yes?
Yes.
Alright, so, just to continue to wrap up, so, RJ, can you read me the first objective, please?
And identify the solution to a system of equations and justify it graphically, algebraically, and or tabular.
Tabularly, so have we done that? Do we understand how to do that?
Yes, sir.
Good, so we've identified solutions, we've looked at graphs, tables, algebraically. Trey, read me the second one.
I can create a system of equations based on a contextual situation.
So when did we do that?
Number one, word problem.
Word problem, right? So we saw a contextual situation, we had to create a system from it. Alright, Amity, read me the third one.
I can interpret the solution found for a system of equations and justify an argument in the context of the problem using multiple mathematical representations.
So that's what we were just talking about, right?
Hey, you read that? Hey.
We had all those representations, and we were looking at how those representations can justify what we said about what streaming service we should choose, right? So, do we feel comfortable with all three of these objectives before we move into the next concept? Yes? Good. Okay, so we did start to hit on this a little bit yesterday, but why do we want to find the solution algebraically like we talked about? What are the benefits of doing that?
But sometimes, like, it takes too long to make a table and a graph.
Yeah, so tables and graphs can take time, right?
And sometimes questions might ask for the algebraic way.
Hey, RJ, can you come here real quick?
Yeah, so they might even ask you for the algebraic. What do you think, so other than, tables and graphs take more time, so algebraically can be more efficient.
So you're not supposed to be down? What?
Also, can you always see from a graph or table exactly what the solution is? When we're looking at a table or a graph, can we always see like exactly what the solution is?
No.
No, right? Because we just looked at one and we couldn't exactly tell. So the algebraic will always give you an exact solution, right? So, what did we say? What was that key word? How did we find that solution algebraically? What did we use?
Substitution.
We use substitution, right? Good. So, I did not hand this out yet. So we're going to look at We're going to look at 5.7. We're going to do a couple practice problems to continue to look at substitution. So we're going to do the set 9 and 10 from what I'm handing you right now. We're going to work on that in groups, and then we'll come together and talk about it. And one thing, I've noticed this with all classes, so I'm just going to go ahead and tell y'all now. Read the directions in these. We are finding the solution to the system, okay? And it literally even tells you, you're substituting x plus 1 into the second equation, or substitute 3 plus y into the first equation, okay? And we're finding a solution. So what do we need when we're looking at a solution? Why can I just find an x and be done?
But you need to find x and y.
You need to find the x and the y, because a solution is what?
Make it both true.
It makes both the equations true. What is it? Like looking at it graphically, what is it on the
A
graph?
point.
It's a point, right? It's a point.
Oh, yeah.
So we need to write it as a point. Okay? So y'all do 9 and 10 in your groups, and then we'll talk about it.
Now, I do want to clarify one detail. Is a solution always a point?
No, sir.
When would it not be a point? Trey, keep your mask up, please.
Equation.
Well, we have actually two equations here.
When it's just one, but it's not a system.
Okay, when it's not a system, kind of, but if I were to have y equals 3x minus 7, a solution in that case would still be a point. What if it was x plus 5 equals 7? How many variables do you have there?
One.
Just one, so would that be a point?
No, sir.
So it is a point when you have how many variables?
More than one.
More than one, right? If it's just one variable, though, do you see how that wouldn't be a point? So I do want to clarify that detail, right? Okay, let's get to work, though. Work well within your groups, talking, discussing, learning,